Across modern SAP enterprise deployments, architecture teams keep introducing a bottleneck into their data supply chain. They take a specialized high-performance planning engine and deploy it as a high-volume data warehouse. This pattern occurs when an organization attempts to push massive volumes of raw, historical transactional line items directly from an ERP system, like SAP S/4HANA, straight into SAP Analytics Cloud, or SAC. The intention behind this design is usually analytical. Architecture teams want to capture the most granular actuals possible inside the planning tool to support detailed variance reporting between budgets and real-time expenses. The immediate symptom is severe operational latency. When an end user initiates a basic input form or triggers automated data actions, the system drags or times out entirely. This failure happens because SAC operates on a multidimensional in-memory model optimized for calculation. Ingesting millions of rows of historical data into that environment bloats the model size past its computational limits. This is a misapplication of the tool's purpose. It treats SAC as an engine for heavy ETL, the extraction, transformation, and loading of raw data, rather than a focused workspace for decision-making. Solving this requires a clear separation of concerns. SAP DataSphere serves as the enterprise data platform to manage the volume, while SAP Planning functions as the specialized data product to drive business outcomes. Protecting the high-speed processing of SAC requires establishing SAP DataSphere as a strict architectural boundary. SAP DataSphere filters and transforms the raw data upstream, passing along only what the planning model requires to function. This matrix shows the required division of labor. On the left, SAP DataSphere acts as the enterprise data fabric. Look at the data scope. DataSphere owns the structural foundation, housing enterprise-wide actuals and deep historical records. Dropping down to operations, DataSphere executes the heavy relational transformations, ETL processes, and data virtualization. For logic execution, DataSphere handles complex table joins and the mapping of business semantics across both SAP and non-SAP systems. If you attempt to process these relational operations inside an in-memory multidimensional structure like SAC, the calculation engine exhausts its resources and crashes. Switching to SAC Planning, the tool consumes a highly curated, aggregated slice of that data. It focuses on the drivers and plan versions needed for specific forecasts. Operationally, SAC is engineered for active engagement. It provides the interface for users to enter data and processes multivariable what-if simulations. Rather than relational joins, SAC's native logic relies on advanced formulas and automated data actions, all executing directly in memory. The data traffic between them is directional. DataSphere pushes baseline actuals upward to the product layer, and SAC writes the finalized plan versions back down into the platform. Confusing these roles forces a planning engine to do the tedious grunt work of a database. This creates architectural debt that eventually renders the planning process unusable. This division of labor becomes more complex when you look inside SAC itself, because the platform maintains two distinct operational tracks. The first is the SAC Business Intelligence track. Its primary objective is descriptive, read-only analytics. The BI track utilizes live and acquired connections to Query DataSphere or S/4HANA in real time. The query pings the database and returns to the screen, bypassing local data replication. This track is built for business analysts and decision makers who need to review high-level variance analysis and standardized dashboards. The planning track functions as a write-back engine, prioritizing the creation and modification of data for forecasting. In a planning model, users modify the dataset directly, submitting budgets, adjusting forecasts, and overriding baseline projections to reflect changing market conditions. This introduces the mechanical requirement of disaggregation. When a user increases a high-level regional sales target, the SAC in-memory engine calculates how to distribute that increase down through hundreds of individual product lines and local territories. This track serves financial planning and analysis teams and operational leads who are actively setting targets. Applying a BI architecture to a planning model prevents users from submitting their adjustments, while applying planning logic to a simple BI requirement creates unnecessary system overhead. To structure this separation of concerns, we rely on the 7-layer SAC planning architecture framework. We will focus on Layer 3, the data integration layer. This is the exclusive domain of SAP DataSphere. Before data reaches the planning tool, DataSphere executes all necessary data quality checks and deep currency or unit conversions. Once the data is refined, it moves into SAC for Layer 4, planning model design, and Layer 5, the planning logic layer. Layer 4 is governed by the principle of the minimal data model. Planners must avoid replicating the highly detailed dimensions found in their ERP systems. As the complex star schema in DataSphere filters up, passing through a tight funnel into SAC, the resulting model captures only the aggregated granularities strictly required to make forward-looking decisions. Layer 5 applies the principle of driver-based planning. The logic built in SAC should forecast future performance based on business drivers, mapping variables like total volume, hourly rate, or headcount. This replaces the legacy method of pulling thousands of historical expense line items and uniformly increasing them by a flat percentage for the following year. A minimal, driver-based data model ensures the in-memory engine remains lean. This preserves the responsiveness needed for users to run complex what-if simulations in real time. Pushing data transformations into the planning layer creates application silos. When you construct complex logic exclusively inside an SAC planning model, that logic becomes locked within a single application layer, invisible to the rest of the business. The DataSphere architecture prevents this isolation. By pushing joins and semantics down into DataSphere, you establish a universally accessible, open semantic layer. This allows the exact same harmonized actuals in DataSphere to simultaneously feed SAC planning models, populate BI dashboards, and supply external consumers. From there, FP&A users take that clean data and run multiple iterations of their plan versions within SAC to determine the optimal business strategy. Once the strategy is approved, those finalized budgets and forecasts are written back out of SAC, returning to DataSphere and core ERP systems. This completes a circuit for consolidated tracking and variance reporting. Adhering to this strict separation of concerns allows an organization to replace bloated annual budgeting processes with responsive, continuous rolling forecasts. In a well-governed SAP landscape, DataSphere prepares the enterprise semantic assets. This allows SAC planning to ingest only the relevant slice of data to drive continuous financial simulation.